Hey guys, sitting at home, wishing I was there with you. I'm not feeling too bad right now, but I had some COVID symptoms this weekend, so I'm getting a test today. Hopefully, I'll see everybody tomorrow. So, what I wanted to do was give you guys everything you needed to get your stuff done so that we can make our models in class tomorrow. So we're not going to make our models today. We're going to bump that till tomorrow, and you're going to work on your worksheet, which means you need me to help you finish your notes today. So I'm going to go over your notes, and then you're going to work on your worksheet on your own quietly, and then we're going to check that in class tomorrow. So of course, if you're watching this, you can see that I've got the daily slide pulled up. That's on your Google Classroom assignment. You can see our 5-Minute Wednesday, so hopefully you already have that copied and in your planner. If not, then you might want to pause the video and get that copied. After you watch this video with me, I want you to go back. I attached your notes into today's Google Classroom assignment. Just go through those, and they're there for you as a reference if you need them to help complete your practice worksheet. After I finish going over the notes with you, then I'll go over a couple of questions on the practice worksheet as well. So it'll kind of give you some free answers and see the rationale behind how to figure out and get those correct answers. If you finish early, then there's also a Texas Gateway link. So you would create an entry in your journal and just take some notes about what you learned and what you did on that Texas Gateway link. This is not going to be graded tomorrow, number 4. That's only if you finish early. If you look at your calendar, you'll notice that you'll have some time later on this week to work on that as well. Okay, so let's get started on wrapping up the notes from Friday. So on the notes from Friday, we looked at pure substances and compared elements and compounds. Remember, we learned elements are just a single element from the periodic table. It can be one atom by itself, or it can be multiple atoms of this, as long as they're the same kind, that are bonded together. So you can have an O atom, an O2 molecule, or an O3 molecule would all be examples of elements. And then we practiced at looking at these containers, and I asked you to choose which ones were the elements. And you chose, hopefully, these 2. So we looked at this one as an example of elements because they're all big blue circles. And then right here we have pairs or bonds of orange molecules, but they're not bonded with any additional kinds of atoms. So orange, small orange are the same. So those are elements. This would be an example of a compound, and this is a mixture, which is what we'll look at mostly in this notes today. We then looked at compounds, and we reviewed the fact that compounds are atoms that are bonded together into molecules, but those molecules have more than one kind of atom present. So this is a molecule with 2 different kinds of atoms. This is a molecule compound with 2 different kinds of atoms, but 3 total atoms. And then this is a molecule compound with 1, 2, 3 different kinds of atoms. But if we look at how many total atoms there are 3 different kinds of elements, I should say, but total atoms would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55 atoms. Wow, that's a really big compound. So it doesn't really matter if it's 2 atoms or 55 atoms, as long as there's at least 2 different kinds of atoms, it's a compound and not an element. And so then we looked at this image and learned that the top row are molecules of elements, because each one of these molecules up top are molecules of the same element, right? So H and H are the same, O and O are the same. And the bottom row are compounds. So N and O are different, H and O are different, O and N are different, O and C are different. So that is looking at that direct comparison of element molecules versus compound molecules. And then we looked at just that word molecule just means two atoms bonded together. We're pretty good on that. And we looked at the idea that when you bond things together, it causes a chemical change. And we talked about that. That's something we're going to look at later next week in distinguishing chemical and physical changes. Today on the handout, you are going to practice with chemical formulas, and so you'll have to tell me how many atoms and how many elements are present in a chemical formula. I think most of us went over this slide. I think we all went over this slide. So we looked here, and we noticed that there's two different elements, H and O. So here we have hydrogen and oxygen in a molecule. And we noticed that this little subscript here tells me what the ratio is. So I've got H2O. That means for every oxygen atom, there has to be two hydrogen atoms bonded to it in a water molecule. So two H's, one 2 and one O. Remember, if there's no number after the letter, it means that there's one. If you ever see a number in the front, that just means how many total molecules there are. So here, this is 2 water molecules. You guys aren't so much concerned with this large number, this coefficient. You are, however, concerned with the subscript. So typically you would just get H2O, and you'd have to tell me that there's two elements, H and O, but 3 atoms because there's 2 atoms of hydrogen and 1 atom of oxygen. And so then we looked at, most of us, I think one of my classes we didn't get this far, but this is just some practice at looking at counting atoms versus counting elements. So if I counted the atoms, actually this asked to count the elements. So if I'm counting the elements in this particular image, I'm looking at 2 elements, O and H, present in water, and 2 elements, C and H, present in methane. So my answer when I'm counting kinds or elements, if I'm just asking for elements, I shouldn't have said kinds of atoms, I should have just said elements, then the answer would be 2. And then here, when we're talking about atoms, we're counting each actual individual atom. So the answer for water in this particular case would be 3, 1, 2, 3, and methane 5, 1, 2, 3, 4, 5 atoms. And here you can look at the subscript, and you can easily tell 5 because you have 2 hydrogens, 2 O, that means 1, so 2 plus 1 is 3. Here, C, there's only 1, there's no number, so you know it's 1. H is 4, 1 plus 4 is 5 atoms. And then it's easy to tell the elements, how many different kinds of elements there are too, because it's just 2 different chemical symbols and 2 different chemical symbols here. Okay? The only time it gets tricky is if your chemical symbol has got a lowercase letter like NaCl, right? So Na, that's just 1 element. And then Cl, again, 1 element. Each one of those only has 1 atoms because there's no subscripts with it, so I would have 1 and 1. So 2 elements and a total of 2 atoms on this one. Okay, here I have 2 elements, H and O, but 3 atoms, 1, 2, 3. And then this one has 3 elements, C, H, and O, but it has 24 atoms because 6 plus 12 plus 6 is 24. So again, those are my answers. Elements, remember, that's the different chemical symbols, how many different kinds of elements there are. Atoms is how many actual atoms are used to make up that particular molecule and what the ratio needs to be. Okay, so we talked a little bit about that if you had a different ratio like H2O2 or HO, then it wouldn't be water anymore, right? So it's the subscripts are super important. This is a slide on chemical equations, and you don't need this until 8th grade, and you don't need it to do your worksheet, so we're going to skip that for today. And we're going to look at mixtures. It looks like I'm coming to my time limit here, so I'm going to stop and start another video.